Hey everybody, it's Erik Torenberg, co-founder, partner of Village Global, a network-driven venture firm. And this is Venture Stories, a podcast covering topics relating to tech and business with world-leading experts. Hey everybody, welcome to another episode of Venture Stories by Village Global. I'm here today with two very special guests, Keenan Johnson, aerospace engineer, and portfolio founder Karan Talati of First Resonance. Karan, Keenan, welcome to the podcast.
Thanks for having us.
Yeah, thanks, Erik.
So, Karan, why don't we start with you? Why don't you just define what First Resonance is and what is the massive problem that you are solving?
Yeah, sure thing. So First Resonance is a software company down in Los Angeles. I'll talk a little bit about my background, but essentially, aerospace industry, automotive industry, manufacturing industry is huge, and they're very legacy. So what we're doing is rethinking how manufacturing is done. There's a lot of things affecting manufacturing even today. We'll get into some of that in the cultural zeitgeist, but what we're doing is making it very easy for engineers to get information into their manufacturing process and then back out in an understandable way that can power better hardware for the future.
Awesome. And how did you sort of navigate the idea maze of wanting to do that, and what was the best approach, and what's the best sort of wedge into that?
Yeah, definitely. So my background comes from, so I studied mechanical engineering and then ended up in Los Angeles to work at SpaceX. We were in a huge scramble to really increase the number of rockets that we were building at high quality. But we were continuing to iterate on engineering, which is very different than how things have been done in the past. You do, 5-10 years of your development process, throw it over the fence into manufacturing, and then whatever happens there, happens there. We were doing everything simultaneously. So that got me really applying software at the problem. A lot of us were applying software at the problem. And interesting things came out of that. And that's what started First Resonance.
One of the terms you were using for a while was you're bringing data science to rocket science.
Yeah, bringing data science to rocket science is definitely one way to look at it. I think even before that is really even just like flexible structures and allowing the collaboration. Manufacturing is a highly collaborative environment. There are multiple different types of engineers applying their skills and their knowledge at one particular component. So even facilitating that and then layering on top, what can you do with the data at hand is what we're doing here at First Resonance.
Keenan, what gets you excited about the space or excited about First Resonance or what brings you here?
Yeah, totally. So I've known Karan for a while. We knew each other from SpaceX originally, and that's where we sort of connected. After that, I went and founded a company doing electric airplanes. So I've been in aerospace for a long time. I'm really excited about tooling that lets us accelerate the rate of innovation. So I don't think that we are lacking for good ideas or necessarily even funding in the innovation space today. But what I see is a lot of companies can't achieve their vision, and I think that's because they just don't have the right tools to do that, especially in hardware and manufacturing.
And say more. What's missing? What needs to be built? Or
I think a lot of things. But if you walk into most big engineering facilities, what you're going to see is like a lot of people with spreadsheets and Excel. There's a lot of manual process that's going on, and I just don't think that that's acceptable. So like what humans are really good at is, taking big ideas and sort of figuring out general directions to do. But what most people are doing is kind of double checking minutia of things that are happening. So like double check that the weight that your one program output is correct in the other program, which somebody had to manually copy. So I think there's a lot of avenues for innovation. I think where Karan's company is working is right now in manufacturing, which is a really old industry that is very slow. And I think that's very exciting.
Totally. Karan, let's zoom out a little bit and talk about the why now for Resonance. And maybe you could zoom out and talk about sort of the historical view of how this space has sort of evolved over time, and then talk about where we are right now.
Yeah, definitely. So if you look back at the history, I think Keenan just talked about it a little bit. Manufacturing is a super old industry. So when it comes to, R&D, science, technology, innovation, we don't really think of manufacturing as that right now, just because of how much the economy has developed. But if you really just even zoom back 100 years, of course, the Industrial Revolution and manufacturing is what set that off. We all drive cars. We all fly in planes. So really, manufacturing brought a lot of this, the technology that we take for granted now into the modern world. But how that has kind of formed over time is that industry has actually hardened quite a lot, rigidized a lot of processes. So in the lack of, and we could kind of get to this point later, but in the lack of really connected workflows that the internet brought on in 80s, 90s, whenever you say it came up after the assembly line for sure. Because of that lack of connectivity, these companies created a lot of processes and rigidized those processes over time. And that has essentially crippled innovation in the way that people work. Now that the internet is here, it's proven out in other markets, and we can do things like hybrid cloud architectures, secure deployments of environments, et cetera. Like, people are really opening up to this idea. There's a proliferation of sensors and just information. Supply chains have globalized. So taking what everybody's running on the internet, but really amplifying that for the purpose of manufacturing, the time is right to do that now. If you look at even the 20th century, right, processes like Six Sigma, Lean, the Toyota production system, et cetera, all these processes and rigid structures came around, and really the technical innovation at that time was the process or the methodology. Whereas now, if you look at it, a lot of innovation is how do you improve the information flow to be so much faster that you can unlock new possibilities, right? So it's not so much about, what matrix can we shove this information into, or what methodology or process does this align with, but rather how can we communicate much faster so that, innovation is significantly improved, right? Whereas in the 20th century, it just wasn't like that. Like manufacturing, robotics, all these things just came up around statistical process control. How do we, continue to hone in on these parameters that we're setting as humans, right? So something happens out in the field, you go take that analysis to a spreadsheet, you come out with an answer, and you just plug that back into the system. Now the system is hardened, right? Yeah. That's not the way that we live. So we even get funny examples of quality inspectors in manufacturing that use Snapchat. I don't know if I've shared this one with you, but use Snapchat to actually communicate to groups, just because when you spot a problem out on the line, whereas before you would take that into a massive PFMEA, failure mode analysis workflow to get to the root cause. Now, this particular company, they're snapping a photo and sending it out to their group so they could quickly triage what's going on and significantly faster, right? And that's really the innovation of the company to move faster. And that's changed from both from the cultural, but as well as the tooling, right? Snapchat didn't exist in the 1960s. So yeah.
Say more about the changing environment here in terms of what new technologies enable or how they change the game.
Let's see. So I think speed of communication is just one. So at its very foundation, the internet, I think is it's just fascinating. When we talk to certain companies, they ask, so this is browser based. How do we deploy this? How do we download it, install it? We hear all these weird words that we definitely take for granted now, right? So at its foundation, the internet, I think on top of that, open source, we used it a lot at SpaceX. We used a lot of open source libraries that were out there. We were trying to move as quickly as, it's interesting even from the software perspective to look at this, but how do you move as quickly as Netflix or Facebook or Twitter? Even though we were rocket scientists, right? So, there's the internet, there's open source, there's the way that you deploy all this stuff. So there's faster and more reliable deployment. So in software, all this kind of, this movement behind DevOps is definitely an important one. So by commoditizing some of these things that used to be really large workflows, right? Things like software development, then testing it, then you have your release engineer, your quality engineer. That used to be the case in software. By making all those individual pieces available to mechanical engineers, electrical engineers, the tooling is now there for them to just solve problems like dynamics analysis problems for a rocket. How do you just use a Python script and then put that into Jupyter Notebook, right? So the analysis part is definitely coming up as well. Data science is doing this in MarTech. There's just a lot of reusable tooling that can now be applied to physical hardware.
Yeah. Say more about shifts in hardware or changing functions of hardware that are interesting or relevant here.
Well, I mean, I think one interesting one that's kind of pushing the industry is 3D printing is a good example. So, traditional manufacturing processes are manual. It's like a person has to go like screw a screw somewhere. 3D printing is a good example of one that is data driven in its root. So there's computers and there's data. So it's sort of forcing a lot of these new toolings into a workflow that is very old as a forcing function.
Yeah, that's definitely true. Additive composites manufacturer, even if you zoom back like 5-10 years. So composites manufacturing is relatively new, but it's much more nuanced in just general kind of metallic manufacturing, casting, forging, etc. So, we look at these platform shifts in hardware and they are happening. So composites, additive, I think one of the really exciting ones that are kind of coming together, of composites and additive manufacturing is generative design. So everything happening in generative design is also interesting, and that's really the coming together of hardware and software. And essentially what generative design is the ability for a hardware engineer to define the overall constraints for what a system is going to look like, and the computer actually figuring out what the optimal geometry of that is, which is very different than how humans have done things in the past, which is like very box, square, or like even spheres at most.
We talked a little about what's led up to this point. Where's everything going? Talk about the future of manufacturing, or how you see this evolving over time.
So I definitely have an angle. There's a hardware perspective as well. I think one of the things that's just super important is this going back to this multiplayer nature of hardware and manufacturing that has always existed. How this has been dealt with in the past is by layering on a lot of systems engineers, managers, just essentially information nodes, if you will, glue people that facilitate the smooth distribution of that information. Now, again, going back to the fact that the internet exists and you can actually do point-to-point interactions where the mechanical engineer can talk directly to the electrical engineer, doesn't have to go through a systems engineer. I think that's going to open up a lot of possibility for people to execute on hardware development in a smaller group. I think small is important for this as well. Because it just speeds up innovation. It takes out those glue people, and you unlock a lot of innovation, right? By a mechanical engineer talking directly to an electrical engineer, you could potentially find a new geometry for how this board is going to fit in this flight computer, for example, right? So that's one area that I'm super excited about.
Yeah, and I think there's a good parallel there to the video game industry. I think it's gone through a similar shift. Like, AAA video games for a long time were these huge shops of, thousands of people to create anything meaningful. We've sort of seen that shift back to like, there's a lot of really small video game studios. Like, you can execute on a really quality video game with 2 or 3 people if you've got an artist and like 1 or 2 engineers, because the tooling, it got a lot better. And I think we'll see that same thing hopefully happen in manufacturing in the next few years.
Where do you guys disagree in terms of how you make sense of the space or how you think about the space? Or
I think we disagree on maybe a couple points. I think that one of the things that I'm not totally sure about is, I know in software we like to talk quite a lot about how software has a really great workflow as an industry, and software has less sort of glue people. I think in really large organizations that's maybe not true in my experience. Like, there's a lot of software that exists in large companies where people are still doing relatively mundane tasks. And so I think there's a little bit of a disconnect between where the industry sort of envisions that it is and where it actually is kind of on the ground.
Yeah, I agree with that. I do think that I think it's very important to recognize the importance of the people that are actually critical for that information flow. I think at big companies, even software companies, things haven't, maybe there are still glue people, But over time, one of the things that I find really interesting about software is that the software industry and like software tangential industries are kind of self-perpetuating. So software engineers that need to improve tooling will go build that tooling and then potentially build big companies off of it. So a lot of these DevOps companies that you might not even, name right out the bat, but like, companies like Twilio, we think about a lot, right? So just telecommunications, text and calling, powering, an entire ride sharing industry. So that's kind of like pain that came out of like this one thing that became a big company. I don't know exactly where this goes for hardware or if you can actually like make things small enough, but I do think that it is related to like bringing the actual engineers that are doing the engineering on the hardware closer together to have those serendipitous kind of conversations and relationships to say, hey, I'm an electrical engineer, I'm a mechanical engineer, I'm a composites engineer, let's go build something. I have a feeling that that's less likely to happen when there's 3 systems engineers and 3 managers sitting in that mix. So
yeah, I think it's hard to say sometimes, like, you as a company maybe have less sort of glue people, but if you outsource, you've got 15 APIs that maybe have like hundreds of employees behind them. Like in aggregate, do you have less glue people? Maybe not.
Yeah,
it's hard to say.
Yeah,
but,
that's true.
But maybe that's okay, and maybe that's how it should be. I know one of the things that we've talked about is so one of the things that the hardware industry is really good at is sort of reusing components. So like in the last industrial revolution, everybody kind of settled down on a few things, like the size of a bolt. Like nobody's inventing new bolt sizes for the most part. Everyone kind of has like a set that they use. In software, we're maybe less good at that so far. We don't exactly have like the same bolt size that we use for, even like there's 1 million ways to create a button on a website, and nobody's really standardized on like how do you do that. And so maybe we need some of that crosstalk happening in software to really accelerate the progress there as well.
Yeah, definitely. That might be true. I think like depending on where you look at, I guess the cycles of hardware and software. So while hardware settled on a bolt size, early on, one of the things that we see a lot is hardware. When it comes to software, hardware companies viewing themselves as snowflakes. So they reinvent software a lot. Like, oh yeah, our process is different because we use a different type of alloy, and therefore we need a completely different issue management system. And so, that's interesting. And then on the software side, it might be like the other side, which the market has especially kind of the developer side of things has by and far kind of coalesced on how you do payments processing through like something like Stripe, but maybe not on how physical appearances are. So like how you make a button, which is, maybe it's next up in line. I don't know. So
maybe I don't know.
Even though payments processing is like maybe way harder. So yeah.
What do you think either of you would need to believe to change views or to come closer to like either something would need to happen or you need to change, get more context on something? Or
one of the things that I often wish is like there's not a lot of good information about like it. Let's say you want to try to quantify like how innovative is an organization, like whatever metrics you kind of use to decide that, like if it's how often you are moving new like features or products or whatever it is, versus like what you planned to do. There's not a lot of great information out there about that. So like I wish that I had a lot more information from all industries about like how good are you at being innovative. And most companies try to keep that a secret, I think, because they're afraid of like that looking bad or whatever it is. But I think that's what I would kind of need to like, say definitively, like, is software industry more innovative than hardware industry today?
I agree with that. I think like at the baseline, like as a world kind of even as software and hardware come together, and definitely newer companies are pushing on this, baselining at just innovation and like value is I think critical. So if we can do that, we could probably make a lot better decisions about where we should spend the time in innovating either hardware or software or software. Yeah, I think what I'd need to see a lot more of is people willing to take best practices and put that and encode that into systems and having like a cultural openness to that. Because I think without doing that and without trying things, both industries, and I think especially hardware is fragile to this. So without actually investing in companies to take their processes and mixing that with every other company that's doing hardware, and seeing what works best. And maybe it's not just one company and maybe it's not just one product, but actually, pooling this together without the hardware industry actually culturally being okay with that, we're not really going to get answers. So that's like one of the things that I worry about for the hardware industry. But I also see it as an opportunity, right? I see like, for example, despite how old it is and things like that, like the DARPA initiatives more recently of like rapid and more modular launch in like the rocket launch space. Like DARPA is actually pushing companies into this, and they're partnering with startups, not necessarily the players of old. And I think that's really where you start to see the needle move in this topic. How do you innovate? What kind of information is okay to share out in the open or internally? So I'm optimistic in that way.
What are analogies, or one or two or more if you have, from other industries that can help us better contextualize what's happened here or what's happening?
Yeah, we talked about a few before. I think one of the interesting ones that we talked about was kind of the music industry is a good analogy. So, a very long time ago, there were very few music distributors and producers. There were a few record labels that controlled everything. We sort of decentralized for a while with the advent of the internet. There were suddenly a lot of producers and distribution was decentralized. Now we're kind of swinging back to somewhere in the middle there. There's today more than there were, but still kind of relatively few distributors, but many producers of music now. So you have like Spotify and iTunes and Google Play and just, kind of a few distributors, but it's very easy to produce music and get that out into the distribution chain. I think for manufacturing, we're still in, there were very few manufacturers and maybe we're starting to see it decentralize. And then what I wonder is like maybe where are we going to kind of re-centralize points where they need to be? Like, is it in software or is it in distribution or what is it?
Yeah. One of the ones that I like, just like, and it's pretty wild, is like advertising. Advertising used to be very centrally controlled, and it seems like that it is continuing to disperse like every day. To the point where an individual Instagram influencer now has like equal weight as like a huge entity did once upon a time. One of the ones that I'm like kind of interested in watching play out is retail. So while there used to be like a few big box kind of like department stores, etc., now it actually got consolidated more, maybe you could say, with like Amazon and Walmart. But now you have, and this is where I get optimistic, is like highly curated experiential retail. Maybe this is limited to the big cities and whatnot. I'm a big fan of Le Labo, so going into like a fragrance shop that will make like an experience for you, curated to you, is something that's much more special than I would be able to get out of Amazon. So we see these kind of like pendulum shifts throughout industries. I think to Keenan's point, there used to be a big few companies in the 20th century, but if you go back to before then, people were just like casting and forging in their own townships, right? So manufacturing came into that through the Industrial Revolution. Now that the internet is there and information moves faster, there's questions around the supply chain. Can that unbundle and then reform itself around innovation, right? As opposed to around large programs or military, whatever that is. Can we actually like align the values of like humanity to just have better hardware in the world around us?
Let's talk about what we've been talking about from a venture perspective. If we were focused on starting a fund that was investing in what we've been discussing, what would our request for startups or thesis be, or how would we think about evaluating what we're looking for?
I think there's a few perspectives of this, right? Like one is on just the hardware side. I think one of the things from a thesis perspective is really how is software, like investing in companies that take very seriously, how is software intertwined with our product and our workflow, and vice versa. So kind of like a full stack hardware software lens on this, as opposed to more of the traditional, kind of like there's a hardware line and there's a software line, and those two are separate. I think that's one interesting kind of thing from the hardware perspective to look at. From another thesis of like just organizational systems, it's I think really a thesis around like what is the future of how people in this space are going to work together. So I think the venture community definitely likes talking about the future of work, but I think more specifically, what is the future of work inside of a factory? Because a factory is kind of a microcosm. It's almost like a city, right? You might have at SpaceX we had 6,000-7,000 people. At Samsung, where I worked, we had a campus of 30,000 people. What are those connection points, and how do you really spur innovation in that? Essentially, like focus products of future of work in the manufacturing context.
Yeah, I think another point that's interesting that I think about a lot is the venture community is very focused on sort of getting sort of predictable returns within some known time frame. That's proving to be very difficult in manufacturing. So any sort of tools or solutions that improve the predictability of an organization to do something in hardware. So like I think Boeing is kind of a high profile example of this right now. They're having all kinds of problems with the 737, and they can't predict when it'll be done. That sort of points to they have like a big systemic problem in how they work. So if you're a company trying to innovate, you need to sort of have some ability to predict when you're going to be done to be successful in the venture world today, I think.
Yeah, definitely. I think one thing to just add on to that, and not to toot our own horn, but we think a lot about the shift in the manufacturing and hardware industry from change control perspective, which has been like very much answering those types of questions around time and delivery to the customer around, does it meet this process? Can we manage the change that's being introduced to the system? And if we can, then we probably have a good idea around what that outcome is. But that's just not true in how fast the world is moving. So, to Keenan's point, not just predictability, but just understanding, right? All the various things that are happening through your supply chain, through your material properties, through the, point-to-point interactions between, for example, that I was going into is a mechanical engineer and electrical engineer, rather than reporting all this stuff into the mothership and assuming that that's going to work out. Like, can we understand this in a much more flexible way? And I think we can with some of this tooling coming up. We just have to connect this tooling up, I think, and that's not without a challenge, but there is light at the end of the tunnel, I think.
Yeah, how does this all relate to sort of public sector and private sector, and how do we think about the interrelationship or connection between the two in terms of this space?
Yeah, so I think through the 20th century, there's obviously been like a huge intertwining between the military and what manufacturing and America's interest in manufacturing was. That's obviously starting to change a lot as people are pushing into the 21st century and innovating. And if you look back historically, like how these projects were capitalized, a lot of what happened and continues to happen in the military industrial complexes through this cost plus structure, where you're really just like paying for development and paying for ideas and R&D until the thing is actually delivered, and you're looking at like billions of dollars. That's obviously not sustainable. Venture does not expect those kinds of things and cannot live within those contexts at all. As the world shifts into that, people are innovating, and the outcomes have to be aligned in certain timelines, and the value of the end consumer. I think there's a huge analogy to be drawn here about like the past 10, 20 years. from the software industry and how it has coalesced these separate functions between development, testing, delivery, and maintenance into this function called DevOps, right? And that it feels like it kind of happened overnight and it just emerged out of nowhere. I think, hardware just has a long way to go in that regard. Yeah.
The sort of traditional government way has sort of been allowing the waterfall development method to exist for a long time. And I think the way the economies of the world are shaping up, that's not really going to be how big projects are funded going forward. You see a lot of the government spending shifting way more into the private sector. And they expect kind of the DevOps, I guess, like philosophy to exist. That's why they're going to private sector.
Yeah, definitely. And I think that goes back to the DARPA example as well, right? Looking for innovation. And I think it's not, to Keenan's point earlier, it's not just like, and actually Keenan said this to us very early on when we were starting First Resonance. It's a quote that stuck in my head for quite a while. It's, we're not inherently limited by physics to push ourselves forward in the physical world. And I think that's key. I think, these government agencies are looking for innovation without actually knowing what that is. But I think it's just higher performance of communication and faster information flow. Yeah.
And venture has historically or recently been sort of challenged by hardware, right? Do you expect that to change over time? Or they've just, the hardware is hard sort of meme. Do you expect that to change over time, or how do you make sense of this?
Well, I think it has to change, or we're going to be in a tough spot as a society, okay. Like as an Earth. Like we have to keep making things, and that means we have to keep funding new ways to make things.
And so, what's going to unlock that change?
I think we're going to have to come up with better vocabularies to talk about some of these problems. Like we can't just say this is hard now. And I think we're going to have to figure out...
Do we need new funding models?
Maybe, yeah. I think that's possible. I think, hardware timescales are long, and so perhaps a different funding model for longer timescales that is not infinite funding would be interesting. But I think even just having a better vocabulary about how do we both accept failure sometimes without failing companies or venture funds as well would be interesting, because we do face sort of unknown problems more in hardware that kind of is more of a test and see what happens result.
Yeah, definitely. And I agree with Keenan that I think it is going to have to change, because we really have two options as a society. Like one, turn inwards and plug into the matrix, or really achieve our destiny and expand out and understand and really sustainably relate to the world around us. So changing the vocabulary, not just calling it a day when a hardware project fails and saying hardware is hard, but what parts of it are hard, right? And really identifying, are these supply chain issues? Is it physical matter, right? Which is likely not. It's not physical matter that's inherently at fault here. So I think this is going to happen through trial and error. People are going to get things wrong. And I think that's one thing that the hardware industry can really learn from venture, is like acceptance of failure. Now when the two come together, acceptance of failure and acceptance of maybe a failure of timeline, which is something that's not compatible with tech, and not incremental progress, but something that's like really step function, is how you unlock these, what hardware has been held back by, right? Yeah.
I think it's a perfect place to close. My guests today have been Keenan Johnson and Karan Talati of First Resonance. We're a happy investor of First Resonance. Guys, thank you so much for coming on the podcast.
Thank you.
Yeah, thank you very much, Erik.
If you're an early stage entrepreneur, we'd love to hear from you. Check us out at villageglobal.vc.